Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 8 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 110. Balanced binary tree. So let's read the problem statement. Given a binary tree, determine if its height balanced. What is height balanced? So height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than 1. So here, if you see this example, so let's pick any node. So let's pick this node. Let's pick this node. So now here for this node, there are two subtrees. One is this side and one is this side. So in this side, the height is 1, right? And in this side, the height is 2, this and this. So the absolute difference between these two, so absolute difference you can say left minus right height. So here it's just 1, right? So the height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than 1. So it is not differing by more than 1. So this is true. Same way we have to check for other nodes as well. Let's suppose if you are here, so for this node, this is one subtree, this is one subtree. So here height is 1, here also height is 1. So the absolute difference is 0 and it's not more than 1, so we are good. Same way you have to check for this one also. So the left subtree height is 0, the right subtree height is 0, the absolute difference is 0. So okay, we are good. So I hope that you guys are clear what is a height balanced binary tree. So height balanced binary tree is a binary tree in which the depth of two subtrees of every node never differs by more than 1. So here we have to first calculate the height. We should know the height. Okay, so first let's see how we calculate the height. So calculation of height is very easy. So here let's say I'm creating one method, okay, and that method is going to give me the height. So here in the height, this is, here I'm passing height. Okay, let me maximize. And I, let's suppose if I am here at my root, so I need the height of left subtree and right subtree. So here in the height I will pass root dot left. That's it. And same way, if I want to calculate the right height, so what I will do, I will just simply write right height is equal to, here this is the height method. In this height method, I'm just going to pass root dot right. This is done. So this is how these two methods are going to give me the height. And I have to compare the height. Let's suppose these two methods give me the height of the left subtree and right subtree. So after that, I have to compare those heights. So here I will write math dot absolute of, here left height minus of your right height, and if the difference is more than 1, if the difference is more than 1, then you need to return false. So I hope everything is clear as of now. Whatever I have written, it's clear, right? Return false here. That's it. So I hope that this part is clear. And here if you see in this same example, if root is null, there is nothing, then in that case you are returning true. So here I'm just writing one more additional thing. If root is equal to null, then in that case simply return true. This is done. Now how we calculate the height, that's what I want to show you. So height we have to calculate. So definitely what I will do here, if I have these nodes, right, let's say this is 3, then here we have 9, then here let's say we have 20, then here we have 15, then here let's say we have 7. So we have to calculate the height. So from here this side I will return one height. So height is 1, this from this side. From this side the height is 2, right? So for this root, what is going to the height? the height is going to be the max of the height that is coming from left side, the right side. So here I will say math dot max of the left height that I'm going to get, or right height, whatever the max I will take. And I have to add the root also, na? So overall tree height I need to calculate. So plus 1 I have to do because I have to count root as well. So this is the formula, math dot max of left height, right height, and in this I'm just going to add 1. So this is what I'm going to do here to calculate the height. So here let me write it like this. Height is the method that we have created. So here inside this we have to return the height, some number. So here public, and I will say int, and here height, and here I have to pass the node, current node. So here what I will do, so left height, how you calculate the left height? So same formula. This is how we have to move to the left, calculate the left height and right height. Left height is equal to height of root dot left. So recursion I'm calling, right? This type of recursion I'm calling. So for this I'm checking the what is the your height. I'm asking him, I want the height here, so I am asking him what is your height, and I am asking him what is your height. So this person, he is going to ask him, tell me what is your height. He is going to ask him what is your height. Okay, so this is how recursion works, right? So this is bigger problem. I want the height here, so this is going to ask this person, tell me what is your height, and this person is also going to ask this person, tell me what is your height. And this person is going to height this person is going to ask this person, like this. So that's why here left height is equal to height of root dot left, and right height is equal to this I'm calling. And I told you what we have to return. We have to return the max of math dot max of left height comma right height, and in this we have to add 1. This is how we have to calculate the height. Okay, but here one base condition let's add now. So here for this one, if I move here but there is no node here, null. If I move here, there is no node here, null. So from here we have to return what? We have to return 0. So this is base case I have to add. So here I will write if root is equal to null, in that case simply return 0. Clear this part? So I hope everything is clear as of now, whatever I did. So here this is how you calculate the height, very simple. And here I'm just doing the basic things, right? Now here from here we are returning false, but in the end I have to check all the nodes, right? I have to check all the nodes. If this is balanced, then I have to check if this is balanced. I have to check if this is balanced, if this is balanced, if this is balanced. I need to check all this stuff. So here what I will do, from here I will return true if the left and right all are balanced. So here I will say is balanced, and here I will say root dot left, and here and is balanced root dot right. This is what I will do, root dot right. And here this is how we are calculating the height. In the height we are passing root dot left. Here it should be root now. This should be root, change it to root. Now let's run it. So see, all the test cases and passed. Now let's submit it. See, we are here. First we are at root. So then after that we are calculating the left height. We are calculating the right height. And if the math dot absolute difference, let's suppose if it is not greater than 1, we didn't return false yet, then we have to then move to the next node is balanced root dot left. So if I am passing this root dot left node in the is balanced, then again I have to calculate the height of left subtree and right subtree. Again I have to check, same way I have to calculate the right subtree height and everything. So again and again I'm calculating the height here. So let's suppose if you have a tree like this, something like this, 1 2 3, and here let's say 100, something like this. So first you are here and you are calculating the height of all this stuff. This is what you are doing, right? What is the height here until here? So you are checking the height by iterating over all these nodes. So let's say you did some n work, then next time you have to check if it is also balanced or not, let's say. Okay, so then you have to check all these. So let's say you did n minus 1 work here, then when you are here, then you have to check for the height of all this. You have to iterate and calculate the height. So then let's say you are doing n minus 2 work. Same way in the end, and there will be case when just one node is here and you don't have to do any work. So it is decreasing continuously, right? Some 3, then 2 work, then 1 work, let's say, then 0 work. So if I just calculate the total work that we are doing here, so it is nothing but 0 plus 1 plus 2 until n. So this is nothing but just sum of first n natural numbers only, that is n into n plus 1 divided by 2, or you can say it is approximately equal to O of n square. That is the time complexity in the worst case scenario. Worst case scenario for such type of tree. You also call this as skewed tree. Okay, so this is the work that we are doing. All right, so now can we further optimize our code to O of n? Can we do it? Let's see. So I hope that you guys are clear with this first O of n square solution. So in O of n solution, what I will do here, so let's suppose this is your example, okay? Or if you want, I can take this example only. 3, 9, 20, 15, 17. 3, 9, 20, 15, and 7. Right? So here what I will do in this O of n solution, so instead of calculating if it is balanced, then if it is balanced, then if it is balanced, and again calculating the height, instead of doing that, in one go I can do this. How I can do this? So let's see that. So first I am here, so I will just simply, from here I will just simply check the height of root. What is the height of root? So here I will just check the height of root. So if the height of root is not equal to -1, I will simply return true. All right, but wait here, let's not move to this part as of now. Let's see what you are going to do. So first you are here, you move to here. This is your left side, you move here. All right, now from here, from this side there is nothing, return 0 height. From this side there is nothing, return 0 height. So in this, total height is going to be the max height from this side, the height from this side, okay, plus 1. So overall height is 1 as of now. Clear this part? So from here you are returning 1. This is a balanced tree. In this case we will return true. Okay, so now here, from here I move to this side, from here I move to this side, then from here 0, 0 I'm returning here, 0 I'm returning here, overall height is 1. That is what I'm returning here, 1. Same way I move to this side, from here I'm returning 0, from here I'm returning 0, overall height is 1 I'm returning, and overall height I'm returning 1 here, 1 here. So for this one the total height is going to be 1 and 1, max is 1, plus this 20 also I need to add, so total height is 2. This is what I'm returning, right? So at every node, if you see, I'm not getting the difference more than 1 as of now. So here 0 0 0 0 0 0, and here 1 1. I didn't get any difference greater than 1 for 20 also. Same way here for 3, 1 and 2, max is, you need to take max, but absolute difference if you see, it's not greater than 1. So 2 plus 1, 3, height is 3. Okay, that's done. So in this case, your final height you are not returning equal to -1, so you are returning true. That's it, true. All right, but few things are not clear as of now in this example, because here this is a balanced tree, but now few things will get clear in this example, because here the output is false. All right, first you move here, then you move here, then you move here, then from here you return 0, you return 0. So overall height that you are going to return is 1. This part done. Same way here, 0 0 here returning, and overall you are returning 1. So from here also you need to return 1. So overall you are returning here is nothing but 2 height, 2 overall. Okay, this is done. Then now see here, this part, from this complete part I am going to return 2 height. From this side if you see, 0 I'm returning here, 0 I'm returning here, overall this is 1 height, and from here I'm returning 1. So now absolute difference is 2 minus 1, it's 1 only, so we are good, still good. So from here overall I'm returning 2, I'm returning 3, sorry, 2 here, 1 here, so this also we have to add now. So overall I'm returning 3 here. Now see here, now see here. Okay, now see here, when you are here, here you are returning 0, and then overall is 1. So from here you are returning 1. Okay, now 3 and 1, 3 and 1, 3 minus 1, if you do, absolute difference is greater than 1. So in this case, if the absolute difference is greater than 1, just simply return minus 1, return minus 1. Okay, return minus 1. So you are returning height as minus 1, and here in the overall function if you see, if it is not equal to minus 1 then we are returning true, but if it is equal to minus 1 we are returning false. Okay, this is what we are doing here. Simple, simple this thing, like this I am moving. But I am going to do few early exit also here. Also in this case also if you see, I am iterating until here, only then I find out that we have to return minus 1. Now see this example. Okay, I think this will help you understand this approach. I draw this tree. Okay, this is going to look like this. Tell me, what do you think? The output of this, is it true or false? True or false? Tell me. Think about it. Right, now let me solve it. I am here, so I am going to call this. Okay, so just see this carefully. I am going to call this. Then I move here and going to call this. Then I move here. I go to call this. Then here nothing, so I'm going to return 0. There's nothing, I'm going to return 0. So overall I'm going to return 1 from here. Then I move here and there's nothing, I'm going to return 0. So 1 and 0 absolute difference is 1, it's not more than 1. So overall from here I'm going to return 2. This is what I'm returning. Now I move here, there's nothing, I'm going to return 0. So now overall difference here is 2 minus 0 from left and right side, which is 2, which is greater than 1. So now in this case I'm just going to simply return minus 1. So I'm returning minus 1 from here, I'm returning minus 1 from here. So now after that, when I'm going to move here, right, so from this left side itself I'm returning minus 1. From the left side itself I'm returning minus 1, right? So if from the left side I'm returning minus 1, so that simply means in the left side I have found a subtree which is unbalanced. So in that case, I'm from here itself I'm going to return false. That's it. This is what we need to do here. Okay, so I don't need to check then further for the remaining part. Clear? So here if you see in these examples, actually we were able to reach to the root, and then we are checking the right side also. We are checking all the nodes actually in this example 1 and example 2, but here we are not checking. So here let me just show you the code here, right? So very simple here. So let's say this is your height, right? So here instead of root, or you can keep it root only, no issues. Here this is how left height you are calculating, right height you are calculating, and this is what you are calculating the overall height including the root. And here in between I will say that if the absolute difference becomes of left height minus right height, if becomes greater than 1, then in that case simply return minus 1. And I told you that we have to return true. Okay, if my height of subtree, if the height at the root level, if overall height at the root level, if it is not equal to minus 1, we have to return true, otherwise we have to return false, right? So here I am going to return true if height of root is not equal to minus 1, right? So here I am returning minus 1 because here the absolute difference becomes greater than 1, right? So here I am returning the absolute difference. Here this part returning -1, but what is the result of the left side? So from the left side, if here from the left side, if I will just add one additional thing. If I don't add this, so definitely my code will fail. Okay, so let me just also remove it now. This stuff is not required here. So now here I'm not adding one additional item here, that if my left height tree is -1, return -1. Okay, so if I don't do that, so and let's just run it and see what will happen. So all the test cases has been passed, but now if I just submit it, this code, so see, this is failing. The same example that I explained, 1 2, this one 1 2 2 3 null. Okay, same example is failing. So absolute difference we are checking. Okay, we are returning -1 from here. So this is the result of a left side. Okay, so here I will add one more additional check. If the left height, okay, if it is equal to -1, then in that case return -1 from here also, otherwise it will just go on. Okay, so here that simply means I will say left subtree unbalanced. Same way here, copy this, add one additional check here. If right height, okay, so here you will say right subtree unbalanced. Now if you submit it, so see, now our solution is empty and we are here. And in this case, the time complexity is now of n. That's it. So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.